It helps when I unmute myself. Thank you, Andy, and thank you to everybody who's here. Like they say in the airlines, we know you had your choice of places to go. And so Rebecca and I are both very excited that you're here. I think, just in terms of introductions, I'll let Rebecca introduce herself, but just for the sake of time, because 45 minutes is going to go by very quickly. My name is Mark Trushkowsky, and I am someone who is very excited to talk about exploring algebraic thinking and mathematical patterns with you all today. This is something that I've been kind of learning about and thinking about and trying to incorporate into my practice for years. And so it's an ongoing thing. And so I'm very excited to kind of engage you all with where I'm at and where you all are as well. Rebecca, you want to say hi?
Yeah, I am Rebecca Strom. I teach in Mankato, and I'm excited to be part of Mark's presentation. I love the thinking, getting more algebraic thinking and things we do and looking for patterns, and I'm excited to be here.
Part of our idea is this idea of algebraic thinking is sometimes people think of it as, oh, that's a cute thing, but algebra is the real stuff and algebra is the real math. And so I want to explore that. I want to push back on that a little bit. Because as I've been learning about algebraic thinking, I've come to appreciate it as something different. And so I want to start with a question that I ask students. And so we don't have a lot of time, so I'm going to give you about 20 seconds. But if you could complete that sentence, that statement, algebra is, and then whatever you'd like to put. There's no right or wrong answers. I won't say there's no right answers. There are no wrong answers.
So go ahead and put your answers in the chat box.
See, right off the bat, exploring the unknown. I'm excited. I feel like I'm on the Starship Enterprise. I'm like, this is an endeavor. Fun, understanding patterns, challenging, thinking abstractly. These are great. I'll give you just a couple more seconds. I type with 6 fingers, so I want to make sure that people who are type like me have time, but 10 more seconds. Anxiety provoking for some, absolutely. And that's kind of at the heart of what I'm trying to explore and figure out how to support students through with what we're going to share today. So you can keep your ideas coming. I want to share a couple of, when I work with students, when I'm teaching, I ask the same question and have them do the same thing. And so I'm going to share just some of their activity, some of their answers. And you'll see some things that are different and some things that are similar. So letters, variables, solving for X, expressions, whatever you do on one side, you have to do on the other. And so, the thing is when I asked this, I didn't plan it the first time I did it. And then the conversation went so well that I now always do it for every semester I'm working with students with algebra. And the thing that I noticed about the list that students came up with is they didn't say endeavoring to explore the unknowns, understanding patterns, kind of the things that teachers, and when I first started, I probably wouldn't have done that either. But they kind of come up with this, like letters and variables, solving for X, all of those things are involved in algebra, but they are not what algebra is. And so I started to kind of think about, and then I started to kind of read about how a lot of the challenges that students face, it starts with this idea of just not having an idea about what this thing algebra is and thinking of it more as just like all of these things that you just have to do and who knows why, but my teachers are making me do it. And so students come up with these kinds of things. The other kind of piece of what always comes out when students said it, and this goes back to the person who mentioned anxiety, is this. These are all things that students have said. Algebra is what makes me want to give up. Algebra is when I left school was like a heartbreaking moment in my class, just to have that conversation with that student. But also this idea that it's pointless, it's confusing, it's frustrating. It's just what are we doing? And I did a quick Google image search for the word algebra, and I put algebra is in, and this is what comes up. Right, so it's of course that's what comes up. That's the idea. Algebra, these things are like cropped pictures. It doesn't even matter what it is. It's just to convey that algebra is gobbledygook. It's just like something that makes you like lean back. And so I wanted to kind of push into that idea because, algebra is something that humans and different civilizations have been doing for 3,000 years, for thousands of years. Like the Egyptians were using algebra to build the pyramids, the Greeks were using it within geometry, the Babylonians in current day Iraq, they were using it in business and to measure land. And it's only for like the last 400 years that people have been using variables, right? But what algebra, like the exploration of it is this more human and much older thing. So I want to kind of pick up on one of the words that came out, and it's obviously in the title of the workshop, but it's where I go with students next. And it's this idea of patterns, because patterns to me, I want to root what we're going to be doing in a very human concept, which is how I think of patterns. And not that humans are the only ones that do patterns, because certainly animals engage with them, plants engage with them, stone, rock, like there's patterns or there's no absence, but there's something about what it means to be human. We all just notice patterns around us. So I'm going to give you another 20 seconds. And if you could in the chat, just complete that sentence, patterns are, or if it helps to think of it more concretely, like where do we see patterns? Either one of those questions. And just take about 15 seconds. Ooh, replication. Patterns exist in everything, everyday life, repetitive sequences everywhere. Methodical, consistent, repeating. So keep those ideas coming. This idea of repetition has come up a bunch of times. And I'm going to share, as I did before, some of the things that students have said over the years. Patterns have to do with our daily routines, the things we do every day. They have to do with dance and with music. We see patterns all the time. The clothing, patterns on our clothing that we wear. I had a student who said, I always date the same kind of clowns. So they're just like dating patterns and behavioral patterns. I had a student who looked very impish, but also a little shy, and looked at me. And if you can't see, she looked at me and she said, it's like if your grandfather is bald, you might be bald, like talking about genetic patterns. Patterns of the seasons, patterns in the days of the week, and patterns in the times of the year, just cycles, patterns in textiles, just in art in general, in jewelry, in nature. I mean, I could have picked a million pictures. I just picked this one of a cabbage that I love. Even cabbages are doing pattern work, in hairstyling and braiding, and in the forecast. And so one thing that kind of I was interested in, and my students were interested in, and we kind of talked about, what does this word mean? How could all of these things that are on that slide be contained within the same word? And kind of what we got to was helpful for us in terms of, how I wanted to connect patterns in algebra, and the idea that, and maybe the weather forecast is a good one to just think about for a second, from the, like that's very, like the weather that we have now is a very scientific, there are all of these ways in which we receive data, but the idea of patterns are the same, right? Humans looked around them and noticed certain things happening, and like when the sky would get dark, it would rain. Like just for this basic thing, it's about making these observations so that we can make predictions, right? And that's kind of and students kind of, that's what we talk about. And even like I had a student who once was super, he knew a lot more about music than I did. And he talked about even in music, when like there's a dramatic key change, or like in the middle of a James Brown song, when the rhythm, like it's, those things only are dramatic and only work because of this ingrained, like we're thinking of a pattern, and it breaks that pattern and becomes interesting to us. And kind of that idea was also, but it all comes down to this idea of prediction. And so kind of that's the word that I want to kind of put out there and have in your heads as we go. And so I'm sorry that I'm talking fast. I'm trying to get us to a Desmos activity, because for the bulk of what I'd like to do for this 45 minutes is give you time to explore an activity as learners. I mean, obviously you'll be thinking about it as teachers and with your own students, but just as a learner, like kind of go through it and think about what you're thinking about the activity. So it's a Desmos activity. So here are some things I'd like you to keep in mind. One, if you're like me, you won't need it necessarily, but it's helpful. If it's helpful to you, you might grab some scratch paper and pen or pencil just to have something if you want to keep it pen and paper. I'm going to stop my share because you're going to be going into Desmos. So I would give your web browser most of the screen, but if it's helpful to keep that chat open, to keep the chat visible, so that if you want to chat or you want to see what other people are chatting, you'll be able to do that. And I want you to work at your own pace, because the activity I'm sharing, we've only got 45 minutes and less than that now. It's not designed to be done with students in 45 minutes. And so I want you to have an experience as a learner with it, but I also want you to have a sense of the scope of it. So what I'm going to ask you to do is work at your own pace, and you're the navigator. When we start, you'll see you'll only be able to be on 2 screens, but then as time goes by, I'm going to open up more and more screens, but you don't have to get to all the screens, right? You're the navigator. You stay on a screen as long as you want, and you can also go back to screens that we've already done. And when I open up a screen, I'll let you know that you can go ahead if that's what you'd like to do as well. And I may be sharing some of your stuff. I just want you to be rest assured you'll be anonymous, so don't worry about that as you're putting in your responses. Your names won't come up. You'll get access to this, so you'll be able to do it with your students if that's something that you are interested in. And we'll talk a little bit more about that at the end. And then just finally, when you click on the link we're going to share with you in a moment, you don't need to sign into a Desmos account. You don't need to have a Desmos account. Your students don't need to have a Desmos account. But if you want to be able to come back to your work later, you do. But if you don't have a Desmos account, I ask you not to sign up for one now. It's free and easy, but maybe just work on the activity, and then we can talk at the end if you want a little support picking up the signing up. So any questions, please stop me. But I'm going to put right now where we're going to go. So if we can go there. Amber just dropped it in the chat. Thank you. So if you click on that link, you'll get to a sign-in page. And again, if you have an account, you can sign in, but if not, you could just continue without signing in. And you'll end up on a screen that looks like this. And it'll have a name here that won't be your name. So that'll be the first screen that you see.
And I will be opening up a chat or a breakout room that is for tech help. If you need to do anything, you can jump into that tech help and ask questions.
Okay, so what we're going to do is I'm just going to ask them to give you about 5 minutes to play with the first 2 screens. You see that there are 18 screens in all, but I'm going to give you about 5 minutes to just explore this screen and the next screen. And then I'll pull us back together every once in a while just to check in, but have fun. We will talk in a little bit.
Okay, if we've got everybody going into the Desmos, do you still want to have the recording on? I know Marissa can change this later, but.
Sorry, I muted myself again. I would say, yeah, we can take it out later, but just in case there's some chatter that happens, I would leave it on, so you have to worry about it. Thanks, Danny.
Not a problem.
You do not have to log in. You can just sign in as guest, just to save some time. So, Shauna, were you able to find the link that he dropped in the chat box?
Shauna, I just dropped it again in the chat for you, directly to you. So let me know if that worked for you.
Hello, Chelsea. We're in the middle of an activity. I will chat you the link to the Desmos activity.
Yep, so for those of you who are saying, okay, I did the first 2 screens, Mark will be opening it up as we are moving along. So if you are done with those first 2 screens, you can either keep playing with that slider or just hang tight and Mark will give you a clue about when we are moving on.
So I'm actually going to move us on right now. But also, like, as you go through these, if you go back, if that'll let you see what other people have answered as they finish. But I'm looking right now at the answers, or the ideas that you guys have put in. As the number of circles gets bigger, there are all kinds of things that people are saying. The area gets bigger, the shape of the figure gets bigger, the number of sections gets bigger. So these are all great, and in a classroom we could explore each of these, but I'm going to focus us. And so if we could all, wherever you are, if you could go right now to the 3rd screen. And actually, maybe I'll just share my screen real quick, just so we can all be looking at it. Because I just want to make sure we're talking about that we're all clear on what it is that we're going to be focusing on. So like I said, you all identified different things that change. But one of the things that changes as the number of circles gets bigger is the number of regions that are formed. And so I just want to be clear what we're talking about when we talk about regions. So here, when these 2 circles overlapped, kind of these colors and these dots show those 2 circles form 3 different regions. So it's the yellow, the red, and the blue. So in the next screen, you're going to kind of explore that idea, the number of regions that are changing, and kind of make connections between, as the number of circles changes, how is the number of regions changes. So I'm going to give you some more time. I'm going to open up screens. You'll have you'll be able to go all the way up to screen 7. Okay. So yeah, so go ahead, and again, if you weren't finished with the first 2, or you still have more that you'd like to do there, please feel free to stay. Okay. Okay, so I just opened up screen 8. So I'm going to give you now just a couple of minutes on this screen. This is a chance to kind of go back to the slider and try your own hand at making some more predictions based on the patterns that you see, kind of building off what you've done in screens 3 through 7. And again, if you're not there, please take your time and there's no need to advance to that. But just for those who are ready to advance, screen 8 is now open. Okay, friends, just to let you know, I'm going to open up screens 9 to 11, where you'll be able to investigate a particular strategy for one student's strategy for figuring out the number of regions. So you'll be able to explore with that. So if you're ready to move on, you can, and if not, it'll be there for you when you are.
Mark, we're showing just 10 seconds left in the breakout room. Do you want me to extend that for the tech help?
Have folks been availing themselves?
Nobody's in it. Aaron jumped into it earlier, but did not stay in it. So nobody's seeming to need it.
Yeah, I would say it's okay to close it, and then just to everybody, if there is a tech problem, if you can unmute yourself and just let us know, and then we'll address it. Maybe we'll jump into a breakout room, but it seems like we don't need one. Okay, once again, wherever you are, whatever screen you're on is exactly where you should be. But I'm going to open up screens 12 through 14, where you'll be able to explore a different strategy than the one that you've been exploring on screens 9 through 11. So I'm going to ask, because I do want to have a little time to talk together. I'm going to ask whatever screen you're on. And again, I promise you, you'll have access to it. You'll be able to, if you keep it open, you'll be able to continue working on it later. I'm not going to give anything away. But I would love if we could all kind of come back together on screen 17. And I'm just would like you, it's a reflection question. I'd like you to think about what kind of thinking you've done. And again, wherever you are, it's the reflection question works. So it's about kind of what you've done up until now. So if you could skip forward again to screen 17, you can always go back to where you were later. So nice, I see you all sliding over there.
Mark, would you want to share slide 17? Everybody should see it on their own screens, but that way we can just pull it up on the main screen too.
Sure. All right, so if you can actually look at my shared screen, if you can come back to Zoom, and if not, you could also just advance yours. But I'd like to look at the results. So you all voted you kind of checked your boxes and you put in, you shared your thoughts at the end. And so now I'd like to, hopefully it'll work. Give me 1 second, I will make it work. Okay, do you all see a bar graph now? Can someone give me a thumbs up or just say yeah?
Yes.
Okay. So what this Desmos activity does is, as students and as you all vote, these are the things that you agreed with, but the things that you saw, that you felt that you were doing. These are all the ways in which algebraic thinking you've used during the activity. You notice patterns, analyze patterns. So we only have a couple minutes because it's very hard to pull you guys away. But I was hoping that we could just spend, maybe a minute, and maybe I'll just ask the question that was in, well, I'm gonna keep it broad. I'm just gonna say, are there any questions, any thoughts, any feedback, kind of where people are? Like one question I'm interested in, but I can read the responses later, but if anyone had something that you wanted to share about, that prompt, I used to think algebra was, and now I think X, but if folks wouldn't mind just unmuting yourselves and you can share. Here, I'll be the first to share my picture of the boundary waters.
So I just wanted to, in teacher mode, I get to read the comments, and one of my favorites I used to think algebra was patterns which were hard to find, but now I think if I can play with them, I might be able to see a pattern. I love that one.
I saw someone wrote, I used to think algebra was abstract thinking, but now I think it can be paired with concrete models, which I was happy to see because that was kind of our goal. Like, that's one of the things that's intimidating and kind of how we often define algebra as abstract, but it doesn't start that way. Awesome, thank you, Chelsea.
Another just favorite one is, I used to think algebra was, I used to think algebra was solving math problems, but now I think it's many different ways of thinking.
There was, I wanted to share, because I think there are a couple of slides that we want to just kind of information. But I did want to go back something that somebody said earlier, which I thought was really interesting. You know, so I'm just going to read. I feel a lot of people skipping straight to the math language confuses the giblets off of our students, which I thought was an excellent use of the word giblets. But that same person wrote earlier that, you know, I think it's elitist to start the formula mindset instead of start with the formula mindset of something more visual. And you know, that's kind of an idea, like starting with the formal notation. Let me put it the other way, like my goal with this is to increase access, right? And I feel like it's connecting to something that's very human is kind of what my goal is. And that sounds very philosophical, but in a classroom, and as you've experienced, I hope like there's a concreteness to that, that I have found success in, but I haven't figured it all out. I'm still figuring out different ways of making it concrete and kind of exploring patterns. And so I'm going to advance my slides real quick. I forgot this was here. The Adult Numeracy Network. If you haven't heard about it, there'll be more information about it on the final slide, the contact slide. But it's basically it's the professional national organization for adult educators who are teaching math, whether or not you only teach math or you teach math at all. It's a great place. Rebecca and I are both part of it, and it's a place to continue that conversation. That's kind of where this conversation got started for me, and where I would love to continue it with all of you. Here's our contact information. I hope that's okay, Rebecca. I didn't ask you if I could play it. But I hope to, I hope we continue this conversation. I hope as you try stuff, if there was anything here that was interesting, I would love to hear about it. If nobody contacts us, we'll take it personally and feel sad. So please inundate our inboxes. I put a couple of resources here. These are just places that I share materials, but there are more important things I need to share. I'll put those in the description on the schedule thing so that you can explore them, or you can take a quick screenshot, because I also just want to say that you all should register for the Math Institute. I think either Andy or Amber will drop the link in the chat to register for it. The focus, I mean, you can see there, the focus in the Math Institute is coherence. Yeah, it's going to be fun. I'm super excited to be a part of it. And then also, where COVID is a thing. And so wherever you are all at with it, if you are comfortable, if you are planning on going to the Minnesota State Fair, Math on a Stick is an amazing thing. I did it. I don't know if I said in the beginning, but I just moved to Minnesota 2 years ago. And within 2 days, the first thing I did as a Minnesotan was Math on a Stick. And it's just a phenomenal experience of engaging with families and people with math. So if you're interested, you can sign up there. Amber, thank you. Just drop the link in the chat. And yeah, Andy.
When you do that, you do get a free ticket to the fair as well.
Right. And so that's all. So we're 2 minutes over. I'm happy to stay I don't know if Andy and Amber, if that's possible, but I want to be respectful for people's time. So I just want to say thank you for participating. Thank you for doing all the work that you did and sharing your thinking. And I look forward to working and talking with you all again.
And session 4 starts at 3 o'clock. So here in about 10 minutes. So thank you all for joining us. We're going to go ahead and stop the recording here.
2 o'clock. 2 o'clock.
2 o'clock.
Yeah, sorry.
I am on the wrong one. The keynote speech starts at 2 o'clock, and then session 4 starts at 3 o'clock. Sorry about that. I forgot we had the keynote between these two. So please go to the keynote speech.
Hey, Mark, there is a question in the chat about having the instructor link and not just the student link. Will both